so today I mentioned to you that we'll be looking at resolution of vectors. Looking at resolution of vectors. And what exactly we mean by resolution of vectors, or we are resolving the vector. What do we mean by that? Resolution of vectors. It is when a single vector is converted into two component vectors, or when a single vector is split into two component vectors. Okay, that is into the horizontal component and the vertical component. So if you look at this vector that we have over here, this one is pointing north at the same time it's pointing east. So when we are saying that we are splitting it into its component vectors, it means that we are splitting it to know the magnitude to which it's acting north alone, and then the magnitude to which it's acting east alone. So if, let's say, we are taking the north to be the vertical, and let's take this to be the horizontal. Okay, and we are saying that we are resolving this vector. It means that we want to know the magnitude to which it is acting horizontally or horizontal alone, which we call the horizontal component. Okay, so we call that the horizontal component. And then we want to know the magnitude with which it is acting vertically also, which we refer to as the vertical component. Keep in mind that when I'm dealing with vectors, okay, I told you earlier that when we say a vector, don't see it to be something so strange, but we've dealt with the examples of vectors. And you know that, for example, a force is a vector. Okay, so when we say vectors, you can replace it with the examples. So you can say resolution of forces. Okay, so that means that you take a single force and then you split it into two component forces. Okay, that is the horizontal component of that force and then the vertical component of that force. So if you are taking a vector like velocity, it means that you can take a single velocity and split it into two component velocities. Okay, so if, let's say, we are using force as an example, so let's say, for example, we take what we have over here. Sorry, I didn't mean to clean this one. Let's say, for example, we take this to be this single vector to be force. Okay, so let's call this F. And we are saying that we are going to split it into the component vectors. So we want to know the magnitude with which this force is acting vertically at F subscript. And then the magnitude with which this force is acting horizontally alone. So we can call that F subscript X. Okay, so that is what we are referring to as Fx. So once again, if you look at these vectors that we are splitting, if we take the of the red line and put it at the end of the blue, okay, you get a right angle triangle. Likewise, if you take a parallel of the blue and put it at the end of the red, you also get another right angle triangle. So for example, if we take a parallel of the blue like this, and we place it at the end of the red. So let me clean this a little. So if it's a straight line like that, and then we also take the same thing off the red and we place it at the end of the blue like this. Okay, so this is the same as F subscript Y. And then the blue is the same as what? The F subscript X. Okay, same in magnitude. Okay, same size in terms of magnitude. So that's fx. Write it all. Good. So then, if you look at the triangle carefully, you can see that we have right angle triangles in there. Okay, so we have the top one, and then we have the down one here. Good. So that alone can help you to resolve to know the magnitude of the vertical component or the horizontal component. Okay. So let's take an example. So once again, let's start with the vertical component, okay, which is the Fy. If you want to resolve, okay, this F, so this arrow over here is representing the F. Okay, that's representing the force F. Okay. If you want to resolve, we've mentioned that these form right angle triangles. Okay, these vectors. So you can see that we have a right angle triangle right there. And if you want to know the value of the Fy, then it means that we have to also know the angles within the triangle. Let's call this angle alpha. And then let's call the angle over here theta. Good. We can also see that we have another right angle triangle down here, like this. So this is our Fy. And the top ones are Fx. So we can focus on any of the triangles to determine the value of Fy. So let's pick one of the right angle triangles. Let's pick the down one. So let's highlight that one. So let's take this triangle. Okay. If we want to find the value of Fy, so it means that we have to apply the trigonometric ratios, okay, which is the SO, Ka, Twa. That's A. Okay, SO, Ka, Twa. Good. So we can focus on the SO, that's the SOH, okay, which tells us that the sine of the down right angle triangle is equal to Fy, which is the opposite, because Fy is opposite to the angle theta. So Fy divided by the hypotenuse, which is the R. So Fy divided. So in that case, if you want to make Fy the subject, that means that Fy will be equal to, you multiply both sides by R. So that will be R sine theta. Okay. So that's the value of what? Our Fy. Good. Okay, on the other hand, if you want to use the top right angle triangle to determine the value of Fy, okay, then it means that you focus on the angle alpha. So the first the top right angle triangle. So in that case, if you want to use the alpha, then it means that if you look at where Fy is adjacent, okay, to the angle alpha. Okay, it's adjacent to it. So since it's adjacent to it, it means you can use the Ka, okay, which is the cosine. So if you are using the Ka, which is the cosine, that means cos alpha, okay, is equal to adjacent, which is Fy, divided R. So then that means that if we make Fy the subject, okay, we get Fy to be equal to what? Or Fy be equal to? Yes. Or Fy be equal to?
R cos alpha.
Yes. Or the Fy be equal to? Daniela, all the Fy be equal to R cos alpha. Thank you. All right. So that means that Fy is equal to good R cos alpha. Y. Okay, so that's the alternative we can use to determine the value of Fy. Either we use R sine theta or we use R cos alpha. Okay, so put this down before we move on to the next slide. Can you let me know when you are done? Can we move on?
Yes, please.
We can move on. All right. Good. So this is how we can determine the vertical component. Then let's see how we determine the horizontal component, which is the fx. Okay, the fx is right there. So if you want to determine the horizontal component, which is our fx, okay, once again, you have to focus on the right angle triangles that the components you are splitting forms with the component vectors there. Okay, that's the horizontal and the vertical component vectors. So once again, if we put our right angle triangles in there, okay, and then we also have over here like this. Okay, we can tell that clearly this is our fx. Okay, and we have a right angle triangle here. Okay, we put our theta here, and then the alpha was right there. Good. So in that case, once again, we are applying the trigonometric ratios, okay, which is the SOHCAHTOA. Okay, so if you are applying the trigonometric ratios, let's focus with the down triangle first, and then we look at the other right angle triangle. So let's highlight this one we are focusing on. So let's deal with this one first. So if you are dealing with this right angle triangle, then clearly the fx is adjacent to the theta. Okay, so if it's adjacent to it, that means you are using the okay, the cosine. So then that gives us cos theta is equal to adjacent fx divided by the hypotenuse, which is the r. Okay, so if we make fx the subject, that means that fx will be equal to r cos theta. Alternatively, you can use the top right angle triangle. So in that case, if you observe what we are seeing here, the fx is opposite to the alpha. So since it's opposite, we use the so. Okay, so which is the sine. So that means that sine alpha is equal to f subscript x all divided by r. Okay, so then that means that our f subscript x becomes r sine theta. Please, I hope you are following.
Yes, please.
Please, I hope you are following. So you can use any of that to determine the horizontal
Yes,
component. Good. So the next one, we'll take an example. So write this down, and then we'll take an example on the next slide. Kindly let me know when you're done. Are you done?
Yes,
Please,
please.
yes.
Did you say yes?
Yes.
Yes. All right.
I,
All right, then let's go to the next slide and take an example. All right, so this is basically a summary of the whole thing. So we had this for the vertical components. Okay, y is equal to r. All right, so this is basically a summary of it. All right, so let's take an example. So example 1 for today. Okay, so find the horizontal and vertical components of the following vectors. Okay, so what I'll do is that I'll do the first one with you, and then the second and the third one, you do it by yourself. Okay, so let's take our first example. So example A. Let's take this to be, we have a vector. So let's take that to be north, east. Good. Good. So we have a vector, okay, it says acting northeast. And we're asked to find the horizontal and the vertical component of this vector. Okay, so it means that you want to know the magnitude of the force with which it's acting vertically alone, and then the magnitude of the force with which it's acting horizontally alone. Okay, so then how do you go about this? Let's start with the horizontal component, then we'll come to the vertical component. So with the horizontal component,
explain the question. Because I cannot
which
see
we are
the
calling
question.
F. Yes, I'm displaying the question.
I can't see.
Please, is she the only one who can't see the question? And the others, please, can you see it?
Yes, please, I can see it.
Please, if you can see it, you can see. Okay, so take a snapshot for her. So you that you can see, log out and log back in. Okay. All right, so basically, in order for us to find the horizontal component, which is the fx, okay, the horizontal component is acting along this line. That's f subscript x. So how do we find the value of that? Okay, remember that form right angle triangles. Okay, so if we want to determine the value of the horizontal component, we can see that it's adjacent to the angle 35. Okay, so using the trigonometric ratio, so okay, we can go for the K. So we can say that if we look at it closely, you can see that the fx, you can say cos 35, okay, which was the theta, our hypotenuse, which is 50 newtons. So that means that the value of our fx is equal to 50 multiplied by cos 35. So if you punch this in your calculator, what will that give you? Yes, what will that give you? Hello?
40.957.
50,
40.
40.957. Okay, so that will give you 40.96 newtons. Okay, so it means that even though the vector is acting northeast, it means that if you are looking at the force with which is acting east alone, that will be 40.96 newtons. That's the amount of force which is acting east only. I hope you are getting me.
Yes, please.
Good.
Yes.
So with the horizontal component, if you didn't want to use the bottom right angle triangle, and you wanted to use the top one, it will give you the same answer. And suppose you wanted to use the top one, this one, to find the value of fx. Suppose you wanted to use the top right angle triangle, then clearly the fx is opposite to the 55. Okay, so opposite, so in that case, the alternative way you can solve this is to get sine 55 is equal to the opposite, so fx divided by the height. So in that case, the fx would be 50 multiplied by sine 55. And what would that also give you? Punch it in.
40.956.
Good. So 40.96 also. So you see that whichever one you use, it will give you the same answer. Okay, so you don't have to do both. You just have to choose one of the right angle triangles. Okay, so if you choose to use the cosine, just use the cosine. If you choose to use the sine, then just use the sine. Okay, you don't have to do both of them to submit it. Just one is enough. Good. So that is it for the horizontal component. So let me clean this one. So what about the vertical component? So if you want to determine the vertical component, which is f subscript y, remember that the vertical component is acting along this line. So, and the vertical component is the same as this one. Okay, the same in magnitude with the side as well. Good. So then we can use any of the right angle triangles to determine the value of the vertical component. Okay, if we want to use the bottom one, then clearly the Fy is opposite to the angle 35. So opposite, since it's opposite, I'm using so, opposite. So you can say sine 35 is equal to Fy divided by the hypotenuse, which is the 50. So if we make Fy the subject, we get F subscript Y, okay, that is the vertical component, will be 50 multiplied by sine 35. And what will that give you?
28.67.
28.67. All right. Seven newtons, very good. So it means that the value or the magnitude of the force with which it's acting vertically is 28.67 newtons. That's the amount of force which is acting upwards. Okay, so you see that the 50 is acting diagonally, but then if you split it into two forces, horizontally to the right. So once again, you can also use the alternative, which will also give you the same answer. And the alternative is to use the top right angle triangle. To determine the value of your Fy. But if you're using the top right angle triangle, you can see that the Fy is adjacent to the 55, the angle 55. So adjacent means ka. So cos 55 is equal to Fy divided by the hypotenuse, which is 50 newtons. So that means that our Fy is equal to 50 cos 55. And what will that give you?
$28.67.
So 6.7 newtons. So whichever of the right angle triangles you use, it will give you the same answer. All right, so put this down, and then the next example, you do it by yourself. When you're done writing, kindly let me know. Please, I you are still there.
Yes, please.
Okay. Please let me know when you're done, okay?
Yes, I'm done.
This example you did by yourself. So find the horizontal component and vertical component of the vector below. Right, so this is question B. So this one, let's deal with velocity. So 20 meters per second. And then so let's take this angle to be 40 degrees. And then the one here to be 50. Okay, so tell me what the horizontal component to be. Tell me what the vertical component will also be. Okay, I'll give you roughly 2-3 minutes and then we discuss it together. So start with. All right. So let's find out. What did you get for your horizontal component? And then what did you get for your vertical component?
Please, for the vertical component,
Uh-huh.
I had 12. For the vertical component, I had 12.86. And the horizontal component,
12.86.
yes, please.
I'm listening.
And the horizontal
What-
component, 15.32.
15.32. Are there no units attached to it?
Sorry, meter per second.
Meter per second. All right, so let's find out and see whether what she's saying is correct. So let's start with the horizontal. It doesn't matter which one we start with, okay? Horizontal component. So with the horizontal component, okay, we can take any of the right angle triangles. So let's take the bottom one. Since we are dealing with velocity, okay, we can use Vx instead of, okay, V meaning velocity. Okay, so it's not set in stone that you should always use F. Okay, F means force, V velocity. So let's use the bottom right angle triangle. So we can see that the Vx is because it's adjacent. So cos 40 is equal to Vx. Okay, some will use Fx, no problem, over the hypotenuse, which is 20. So that means that our our horizontal component and 20 cos 40, what will that give you? 15.32. 32 meters per second. Okay, that is for the horizontal component. Now for the vertical, so let's call that V subscript Y, since this is Vx. So for the vertical component, you know the vertical component will be along the vertical line this way. Which is the same as this one. So 40, which is the hypotenuse. So that means that will be equal to 20 cos 40. And the 20 again, opposite. So sine 40, okay, sine 40 rather, is equal to Vy over 20. Okay, sine, not cos, because it's opposite. Okay, so it means that Vy will be 20 sine 40. Please, I hope it's making sense to you. So 20 sine 40, what did I give you?
$12.86. 12.86
meter per second. Good. So that means that, okay, if let's say we have an object which is at this point and is moving along the diagonal with a speed or a velocity of 20 meters per second, and we can see the angles to which it's making with the vertical and the horizontal. It means that if you're observing the speed or the velocity, okay, along the horizontal component or towards the east, you see it moving with 15.32 meters per second horizontally. And if you're observing the speed with which it's moving vertically, and when you see it moving with 12.86 meters per second, but diagonally is moving at what? 20 meters per second this way. So if diagonally is moving at 20 meters per second, so you can even picture it as a car which is driving northeast, okay, along a straight line, and is moving with a speed of 20 meters per second northeast. Okay, if you are observing the speed moving east alone is moving 15.32 meters per second, and if you are looking at the speed with which is moving north alone, is moving with what? 12.86 meters per second. So this is what we mean by you are resolving the vector. Okay, you are splitting it into two components so that you know the magnitude with which is moving vertically alone and the magnitude with which is moving what? Horizontally alone. Okay, so that is what we mean by what? Resolution of vectors. You are taking a single vector and you are splitting it into what? Its component vectors. Please, I hope it's making sense.
Yes.
Yes, please.
Good. So you can take
Yes.
a screenshot of this. Those who are able to take screenshots, you can take it. All right. So let's move on to the last thing. I know our time is up. Okay, our time is up. So let's just do the last slide. When we come back, whatever time we lost, okay, we'll try and add it to it. All right. So this is the last thing that I want you to take note of. This is the last thing that I want you to take note of. Okay, before we close, that appropriate signs must be attached to the components. Okay, anytime you are resolving components, you have to attach the appropriate signs to it. So by convention, take note that components pointing northwards or eastwards are positive, and components pointing westward or southward are negative. Okay. So anytime you split it into its component vectors, okay, if it's pointing northward, you can attach a positive sign to it. And if it's pointing eastward, you can also attach a positive sign to it. And if it's pointing southward, so then the minus that we put in front of this is just indicating direction. Okay, telling that it's going the opposite direction. Okay, so we'll end here for today. When we come back, we'll take examples on this and then we'll make it clearer for you. Makes sense. Any questions? All right, if there are no questions, then let me put your homework down. Very simple homework. Of the following vectors. So this is assignment 3. Okay, so I'm taking note of the assignments I'm giving to you and those who are submitting. Okay, I'll put the list there very soon, and you know whether you've submitted or whether you've not submitted any at all.